In this video, we're going to look at some different components for vectors. So we're going to first just take a quick look at scalar multiplication. So we've got vector v here, and we want to think about what would happen if we multiply this vector by some scalar. So if we've got 2v, 1/2 v, or negative 3/2 v, what would the vector look like by multiplying it by these numbers? Well, if we've got vector v right here, 2v, well, that kind of makes sense that we would be doubling our vector, so it still has the same direction, but the length is going to be twice as long. Similarly, if we take 1/2 of v, we're going to go same direction as our original vector v, but now our magnitude, the length is only going to be half the original length. And if we have negative 3/2, well, we're going to take 3/2 of this length, so 1.5. See how it does look a little bit longer. So if we were to add this 1/2 to it, that would be 3/2. But then negative, that changes our direction. We flip it and we go in the opposite direction. All right, so a little bit more with vectors and components. First, we're going to look at unit vector. So we've got two different unit vectors here, I and j. And the basic rules for an XY grid apply for our unit vectors. So the unit vector I represents a horizontal vector of magnitude 1. So notice how this one in particular is going to the right. That's because along our horizontal axis, we know that to the right is a positive direction. If we were to go to the left, so if we saw this vector go to the left with a magnitude of 1, well, that would be negative I because that's going in the negative horizontal direction. Similarly with j, this is kind of like our y. That is a vertical vector of magnitude 1, and if it were to go down, then we would have negative in front of that vector. So let's think about what these vectors would be as we represent them with the components I and j. So take a moment to think about how you could write these. Don't think about the location of them, just think about the direction and magnitude. Well, this one's going in a vertical direction, and it's positive because it's up, and it's a length of 3, so we would say that this is represented by 3j. This one here is going to the right with a magnitude of 6 in the positive direction, so we call that 6i. This one is also going horizontal, but it is going to the left. It's a negative direction, so we would say that this is negative 3i. And then this one is going down 2, so we would say that's negative 2j. All right, so let's go ahead and draw the given vectors here. We're just going to say that all of these have an origin, or they're starting at the origin, 0, 0. So go ahead and draw this one out. 3i, well, that doesn't have a j component. It just has an I. We see how these two, okay. These other two that we've got have both. This one is just 3i, so we're just going straight to the right, magnitude of 3. Okay, so that's 3i there. Negative 2j, since that's just j, we're just going to go down 2, so that would be represented right here. This one has both components now, so think of it just like an ordered pair. We know that I is horizontal direction, so we're going to go negative 7 to the left, and plus 5j, well, this is like the y term, so we're going to go up 5 This one in red. So we're going 1, 2, 3, 4, 5, 6, 7. And we're going up 1, 2, 3, 4, 5. So this one would be negative 7i plus 5j. And then the other one was negative 2i, so we're going to the left 2, minus 4j, so we're going to go down 4. Shoot, I gotta scroll down a little bit. So we went over 2, and now we have to go down 4. So this would be negative 2i minus 4j. Okay, so now we're going to write this vector here as a sum of its components. So that's the components I and j that we just talked about. So I see that it is going to the right 4 and up 2. Right, so we're going right 4, up 2. Okay, so we would say that vector A is going to be equal to 4i plus 2j, and just throw arrows up there so we have the correct notation. No, a little small. Okay, so if we're asked to write a vector as a sum of its components, we would need to write it like this. Now we want to find the magnitude of the vector and the angle in standard position. Okay, so our vector A is right here. We want to find this distance and the angle that we have here. Well, that's just using what we know about trig, and we're going to start with our Pythagorean theorem here first to find the magnitude. So we've got 4 squared plus 2 squared equals a squared. So we're really just taking square root of 4 squared plus 2 squared. We get 4.47 if we were to use a decimal and simplify our radical. Okay, so there's our magnitude. Remember the way we would write magnitude of a vector, it's the same as absolute value, so we would have to put our absolute value lines around that vector there. And then our angle here, well, I'd rather use the numbers that are given that don't have decimals, and that's the opposite side and adjacent, so I'm going to use tangent. So tangent of our angle here, theta, would be equal to the opposite 2 over adjacent 4. So I'm going to need to do inverse tangent of that ratio 2 over 4. And we get 26.6 degrees if we round to just one decimal. Let me make sure I'm in degrees. Yep. So 26.6 degrees for our angle in standard position. Okay, last piece here. If we're adding vectors using their components here, Well, we've got these two vectors here, vector b and d. And if we have to find what vector b plus vector d is using its components, we are basically looking at these like as like terms. So we are going to combine the I vectors and our j vectors. And so vector b plus vector d is going to be equal to, change back to black. Well, 4i plus negative 5i would be negative 1i. And negative 6j plus 6j, excuse me, negative 9j plus 6j would be negative 3j. So, vector b plus d would be equal to negative 1i minus 3j.